Good afternoon. I'm Katie Yu from Carnegie Mellon University. I'm sorry I could join you guys in person, but I'm very happy to be presenting our joint work, Gender Homophily and its Role in Open Source Software Developer Retention. So today I want to talk about a question at the intersection of social networks and software engineering sustainability. Does it matter who you collaborate with? And specifically, do gendered collaboration patterns influence whether developers stay or leave open source? The answer is yes, but to get there, I will walk you through the evidence from our large-scale observational study. So the motivation for this work sits between two well-established findings in OS's literature. On the left, the prior research showed women face higher dropout risk in open source than men. And on the right, prior research also shows social ties support retention. Stronger social capital and repeated collaboration are associated with longer participation, and belonging appears to be a key driver of sustained engagement. So both findings are well documented, and what hasn't been directly tested is whether a specific structure feature, the gender composition of a developer's collaborators, connects the two. And that's our question. So if the answer is yes, prior literature already tells us whether the mechanism likely lives, like through belongings, through bonding social capitals, or through diminishing returns of additional ties for the majority groups. We will return to this mechanism after the results. One note on terminology before we proceed, you will hear me say women and men throughout. That's because our data relies on a name-based gender inference, which is binary. And this is a real limitation, and I will return to it at the end. But to answer our question, we first need a theory that tells us what to look for. So our theory anchor comes from outside of software engineering. The concept of homophily, which is the tendency to form ties with similar others, is a foundational finding in social science research, documented across organizations, public health, education, and science teams. The part that matters for us is that in skilled settings, when one group is much more smaller than the others, homophily operates asymmetrically. So the diagram here shows the majority case where the network supplies both instrumental and expressive function by default. So no dual use structure is needed for the majorities. And we can see the diagram on the right. It shows minority case where the minority members maintain dual networks with instrumental ties to the majority for resources and access and expressive ties to same gender peers for support and identity. So the minority relies on same gender ties for something the majority gets for free. And for open source, the gender composition is deeply skewed. Women are 2 to 5% of contributors, which is exactly this kind of setting where the theory should apply. So from the dual network theory, we derived two predictions. H1 is the structural side. So if the theory applies to open source, we should see asymmetric homophily, where women, the minority, should form same-gender ties above what random chance would predict. And men should not, because the majority doesn't need the dual structure. H2 is the retention side. So if same-gender ties do the work that social capital and belonging capture at the aggregate level, having one should reduce dropout risk. And the predictive effect should be larger for women than men, because only the minority relies on same-gender ties for something the majority already has. Two predictors derived from the theory, testable on ecosystem scale data. So the rest of the talk is how we test them. Our analytical pipeline has three stages: data preparation, network construction, and three complementary analysis. Starting with our data, we used the Word of Code dataset, which gives us 14 years of open source collaboration from 2008 to 2022, 2.8 million developers, 1.65 million repositories, and 38 package ecosystems. With the alias email addresses to consolidate developers who use multiple accounts, remove bots and organizational accounts, Restrict to contributors with at least 2 commits in a calendar year and split everything into 14 annual windows. Gender of each developer is inferred from developer names using a tool called NameSort, which is an origin-aware tool that accounts for cultural variation in name gender associations. We apply a 0.7 confidence threshold, meaning we assign a binary label only when NameSort is at least 70% confident. This yields roughly 66% men, 2.7% women, and 31% unknown. These are inferred labels, not self-identification, and we treat them as a measurement limitation throughout. So for each annual window, we then construct an undirected collaboration network. Nodes are developers, and we draw a tie between two developers when they co-contribute to at least two shared projects in the same year. The two projects threshold is deliberate. It captures sustained collaboration rather than incidental co-occurrence. Lastly, the three analysis on this network. First, observed to expected ratios test whether same-gender collaboration exceeds chance. Second, we used a method called exponential random graph models, or what we call ergms. The intuition for this method is basically logistic regression for network ties. It tests whether those patterns persist after controlling for network structure. Lastly, the survival analysis using Koch's proportional hazard regression model, how the network composition relates to whether developers stay or leave. The sampling design and robustness checks are in the paper, and we will move to the results. So for our hypothesis 1, it predicts asymmetric same-gender type formation, and the figure tests it directly. The y-axis is the observed to expected ratio, the number of collaborations of given type we actually see, divided by the number we would expect if collaborations were random. A value of 1 means exactly what random mixing would predict, and greater than 1 means more than chance. So the green line here is a woman-to-woman ties, sits consistently above 1.2 every year for 14 years. And at the peak, women collaborate with other women at more than twice the rate random mixing would predict. Men hover right around 1, and this is exactly the asymmetry theory predict. The numerical minority leans on same-gender ties, while the majority does not. The same pattern holds under the stricter ergm test, which rule out structural opportunity as a sole driver, which you can see details in the paper. But hypothesis 1 is only the setup. The question that matters is whether any of this translates into who stays. So to test H2, we modeled time to drop out with a Koch's proportional hazard regression, which has at least one same-gender collaborator as a predictor of interest. So the current panel shows a baseline specification. For both women and men, the coefficient is statistically indistinguishable from 0. Taken at face value, same-gender ties appears to have no effect on retention. But the baseline ignores a structural feature of the data. The degree is extremely right-skilled, where a developer with 1 collaborator and a developer with 300 faces fundamentally different baseline hazard, and their opportunity to form cross-gender ties differ by orders of magnitude. We therefore stratify on activity, restricting the sample to developers with sufficient degree for meaningful exposure to the full collaborator pool. The right panel shows the stratified estimates. Women with at least one same-gender collaborator show a 20.7% reduction in dropout hazard relative to women without. For men, the reduction is 10.1%, so both coefficients are statistically significant. And H2 is supported, and this asymmetry predicted by theory is recovered in the data. So the natural follow-up question is what mechanism generates this asymmetry? And as previewed at the start, 3 complementary accounts from prior literature, including belonging, bonding social capital, and diminishing return for the majority, each predict a larger effect for women than for men. Distinguishing among them is work we want to do qualitatively next. So the finding carries three implications. For maintainers and tool builders, the results suggest that who developers are connected to is not only a matter of technical fit. When recommender systems surface potential collaborators with mentorship program pair participants, when onboarding suggest reviewers, preserving the same gender peer ties for developers from underrepresented groups may carry measurable retention benefits. For diversity programs, this result suggests that affinity spaces may help generate a measurable structural condition associated with persistence. And for researchers working on retention or diversity metrics, the methodological finding is consequential. Aggregated models that do not stratify on activity can produce null results or assign reversals on effects that are, in fact, exist. Three limitations frame this results. The analysis is observational, so associations should not be read as causal. Gender is inferred from names and treated as binary. Neither reflect a theoretical commitment. And the mechanisms on the slides before remain hypotheses to be tested qualitatively in the follow-up work. Paper and replication packages on the QR code, my email on the side. Thank you, and I'd love to take your questions.